Welcome to JEV Civil Corps. If you're gearing up for the SSC JE exam, you know questions on concrete are pretty much a guarantee. So today, we're going to cut right through the noise and focus on the absolute core concepts you need to nail down, the difference between PCC and RCC, and how to read concrete grades like a pro, all according to the IS 456 code.
So here's our game plan. First, we'll lock in the fundamental difference between PCC and RCC. Then, we're going to decode those concrete grades so you know exactly what M20 really means. And finally, we'll tie it all together by looking at how real-world conditions affect our choices. Sound good? Let's jump in.
All right, first things first. Let's get right into the fundamentals. It's a really simple distinction, but honestly, it changes everything about how we build our world.
At its heart, you can think of concrete like a simple recipe. You've got cement, which is basically the glue. You have your aggregates, the rocks and sand, which are the fillers, and you add water to kick off the whole chemical reaction that makes it hard. But the simple mix is transformed by one key ingredient. And this right here, this is the secret ingredient, reinforcement. See, PCC, or plain cement concrete, is just that basic recipe. It's fantastic at resisting being squeezed. That's what we call compression. But it's just terrible when you try to pull it apart. That's tension. So RCC, or reinforced cement concrete, brilliantly solves this problem by embedding steel bars inside to handle all those pulling forces. And this is where the magic really happens. It's all about teamwork, right? This composite action is perfectly summed up here. The big, bulky concrete takes care of all the squeezing forces, while the strong, slender steel bars inside handle all the pulling and stretching. Each one does what it's best at.
You might be wondering, why steel? I mean, why not something else? Well, it turns out steel is pretty much the perfect partner for concrete. For one, when it gets hot or cold, it expands and contracts at almost the exact same rate as concrete, which is huge for preventing cracks. It also forms a super strong bond, has incredible strength and tension, and, this is key, it adds flexibility, or what we call ductility, to a material that on its own is pretty brittle.
All right, so now that we know what RCC is, how do we actually talk about its strength? This is where grades come in, and trust me, this is an absolutely critical topic for your exams. So how do we actually put a number on this? How does an engineer say, I need this specific strength for a massive column versus something else for, a simple pavement?
The answer is something called its grade, and the way they label it is actually pretty simple. You'll see an M for mix, and the number right after it, that's its characteristic compressive strength in newtons per square millimeter, measured after it's been curing for 28 days. So if you see M20, you instantly know its target strength is 20 newtons per millimeter squared. Easy, right?
Now, to make things even easier, the Indian Standard Code IS 456 breaks these grades down into three main groups. First up, we've got what's called ordinary concrete. These are your M10, M15, and M20 mixes. You can think of these for more basic stuff, leveling beds or simple PCC jobs where you don't need massive strength. But when the stakes get higher, for the really important stuff like the columns and beams in a building, we level up to standard concrete. This is a huge range, going from M25 all the way up to M60. And for the really ambitious projects, we're talking skyscrapers, massive bridges. That's where you'll find high-strength concrete, from M65 on up. And here it is, the whole shebang. This table lays out the entire range specified by the code. Just take a look. You can really see that clear jump in strength as you move from ordinary to standard and then up to high strength. This is one of those tables you'll want to get real familiar with. Okay, if there's one number you need to remember from this section, it's this one, M20. As per the code, M20 is generally considered the absolute minimum grade you should be using for any significant reinforced concrete work. You're going to see this question for sure. But hold on a second. Is it all about strength? Not even close. See, a building doesn't exist in a vacuum. It has to survive in the real world, right? And that brings us to the all-important topic of durability, which leads to this really critical question. Let's say your structural calculations tell you that you only need M25 strength for a beam. So you just use M25, right? Well, what if that beam is part of a coastal bridge getting splashed by seawater every single day? Well, the code says absolutely not. Strength is just one piece of the puzzle. The very first thing you have to do is figure out the environment it's going to live in using these 5 exposure conditions. It could be mild, like an indoor column that's always protected, all the way to extreme, like a structure that's literally in the tidal zone of the ocean.
All right, get your phones out, take a screenshot of this, write it down, whatever you have to do. This table is pure exam gold. It connects the dots, it tells you the minimum grade you have to use for each situation. So back to our bridge example. Even if your strength calculation said M25 was okay, this table would tell you that for a very severe exposure like sea spray, you must use at least M35 for RCC. Durability is king.
And let's be super clear about this. This isn't just a suggestion. It's not a nice to have. This is a non-negotiable, mandatory requirement from the code. Why? Because we need our structures to last for decades, not just look good on opening day.
Okay, that was a ton of information, I know. So let's boil it all down to the key things you absolutely need to remember for your exam.
Here are your 3 big takeaways. Number 1, RCC works because steel takes the pulling forces, the tension. Simple. Number 2, that grade number, like M20, tells you its compressive strength after 28 days. And number 3, this is the big one. Choosing a grade is a 2-step check. Is it strong enough? And is it durable enough for the environment? You've got to check both boxes.
All right, to finish up, let's put it all together with a classic exam-style question. Look at this slide. You have an RCC column and it's getting hit with seawater spray. What's the minimum grade you have to use? Think back to that table we just looked at. Go ahead, pause if you need to, and drop your answer in the comments below. Thanks for watching, and we'll catch you in the next one.